is. Here's number 26. Notice right away this is an x as a function of y, and that'll be for y. It goes from 0 to 3. So this, of course, is 36 minus y squared to the half. I am going to need the derivative in my formula. That's going to be 1/2 36 minus y squared to the negative 2y. The 2's will cancel. I can send this guy on the bottom. It's the square root of. So that's my dy dx. I'm ready to plug that into my formula for the arc length. So it's from y equals 0 to y equals 3 of the square root of 1 plus dx dy all squared, which will be the square of that expression. So when I plug in that expression, I then square. I have y squared. Square the square root disappears. I'm going to find a common denominator. I'm going to simplify the numerator. I'm going to break it up. Square root of 36 is 6, which I pulled out in front, over the square root of 36 minus y squared. And this is an inverse sign, because that is the square root of a squared. If a squared is 36, a is 6. Y squared, if u squared is y squared, u is y, and du is dy. So that's 6 times the inverse sign of u over a, which is y over 6, from 0 to 3. Plug in the 3, you get inverse sign of a half, minus, plug in the 0, you get inverse sign of 0. The inverse sign of a half is pi over 6, and the inverse sign of 0 is 0. And then 6 times pi over 6 is pi. Number 28, kind of popular on the AP exam. Okay, so you have this graph. You have the integral from 0 to pi over 4, the square root of 1 plus d dx of tan all squared dx. So this is your derivative of your tan function, so your function must be tan. It's going from x equals 0 to x equals pi over 4, and we're actually finding the arc length on the graph of y equals tan between where x equals 0 and where x equals pi over 4, which would be this red region right here. Okay. Now, we do actually need to look at the question for this so you can see what's going on. This is number 28 of 7.4. I'm going to pause this while I find 7. Okay, so we're back. So numbers 27 and 28, it says determine which value best approximates the length of the arc represented by the integral. And it actually goes on to tell you make your selection based on the basis of a sketch of the arc and not by performing any calculations. Because you wouldn't be able to integrate them anyways by hand. So if we look at number 28, 0 to pi over 4, square root of 1 plus. So if we go back to the question, it did say d dx of tan x. So tan x is our function. So if we actually graph the function, y equals tan x, and you highlight that portion of the graph between 0 and pi over 4, that's the length we're looking for. That's the arc length we're looking for. Now, we're not going to do a calculation. Anyway, so we're looking for this length of this arc. We're not going to, because the derivative of tan is secant squared, and this would end up being secant to the 4th, and you'd have the square root of 1 plus secant to the 4th. That's just like never happening. You will not be able to integrate that. But we're looking at it graphically like they told us. So you can see that this red arc would obviously be longer than this diagonal. You know that this is the point 0, 0, and that's x equals pi over 4. And of course, the tangent of pi over 4 is 1. So if you took this, pi over 4 is approximately 3/4, right? Pi is approximately 3. The height of this right here is 1. And so by the Pythagorean theorem, the hypotenuse would be the square root of 9/16 plus 1, which would be 25/16. Square root of 25/16 is 5/4, which is 1.25. And therefore, the closest thing to it would have to be something near 1.25. So if you look at the answers, you have -2, which of course would make no sense at all. It's a length, it's positive. And what did we get? 1.25, so the closest answer would be 1. 3 is way too far away from 1.25, as is 4. And if you rounded this to 3, this is also very close to 4. Okay, so that we're doing that actually graphic.